Hello once again, ladies and gentlemen, and welcome back. Root Beer here with more of the 2001 Fermat paper. That's the multiple choice grade 11 contest. And we're on question number 14. The last digit, that is the units digit of 2002 to the 2002 is... That's kind of odd. Usually you don't see a number close to the year. This is the 2001 paper, but we've got 2002 here. I would expect this question to appear on the 2002 Fermat, so I'm a little thrown off. But it's probably because the ones digit of 2001 to the 2001 is just 1. You can verify that really quickly. So they altered the question a little bit. So last digit, and we've got 2002 to the 2002. Okay. Well, what we can try and do is grab ourselves our calculator and start computing powers of 2002, but those are going to grow very quickly. I don't care how big your calculator screen is. So the next option is to take a look at just the 2 here, this 2 right here, this units digit of 2002, because it's exactly the units digit that influences further units digits. So for example, if I take a look at 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and look at the units digits, so that's 2, 4, 8, 16, 32, I get units digits of 2, 4, 8, 6, and 2. And if I look at powers of 12, I will notice that the fact that I added a 1 up here doesn't make a difference. 144, I think it's 1728, but I will grab my calculator and make sure I'm doing proper calculations on air. Yep, 1728. Then 20,736, and then 248,832. But if we just look at the units digits, we have again 2, 4, 8, 6, and 2. So this comes from sort of a small branch of mathematics called modular arithmetic. But we can summarize this. The units digit depend only on the units digit of A. Now let's change that to N because A can sometimes be confused as an actual word. Okay. Notice that this is not true of the tens digit. The tens digit relies on the tens digit and the units digit, but does not get impacted by the hundreds digit, for example. Alright, so the units digit only matters in terms of the powers of N. And when we look at numbers with units digit of 2, we notice a pattern. It goes 2, 4, 8, 6, 2, 4, 8, 6, 2. It's just going to repeat. If we did 64, which is 2 to the 6, we'd be back here on our cycle with the 4. So we sort of cycle through here. So we have length 4 or period 4, however you want to call it. So really, if we're raising 2002 to the 2002, we just have to ask what is the 2002 term in our sequence. Well, our sequence repeats every 4, so it might be a good idea to figure out the remainder of 2002 when we divide it by 4. So remainder when we divide by 4 is going to be 2. You can work that out with a calculator, or you can realize that it's 2 away from 2,000, and 2,000 is a multiple of 4. We had a leap year in the year 2000. But that's not so much because it's a multiple of 4, but because it's a multiple of 400. Look up calendars. That's an interesting story of how leap years are calculated. So when we divide by 4, we get a remainder of 2. So that means we should be at the second term in our sequence. So notice that we have our first term, our second term, third, fourth, fifth, sixth, seventh, eighth, ninth. So when we divide by 4 and we get a remainder of 1, so we 1, 5, and 9, we get 2 as our units digit. When we divide by 4 and get a remainder of 3, we have 8 as our units digit. Well, here we divided by 4 and had a remainder of 2. So 4 is our units digit. And that was one of the answers. I believe they only gave us even numbers as possible answers. There we are, and A4. Okay, so that's question number 14, a nice little question. Join me in the next video for question number 15, which I will start recording shortly. So thanks for watching, and I'll see you guys, as always, next time.